Notebook, unless there's someone who is not familiar. Is there someone who is not familiar with the notebook? Are we familiar with this thing we're using?
Yes, sir.
Okay, so basically what I'm doing is your labs, the labs for the course. Previously, the course was taught in Python, in Fortran, as you can see from the thing I sent you. However, I'm not conversant with Fortran, so I asked for permission so that I could teach the course using Python, because at least I know something about that. So that's exactly what happened, and I was given permission. However, I could not also do a lot of things from scratch, because a lot of work had gone into making the lab manuals. So I could not actually from scratch create a new lab manual. So I have to use the old lab manual and focus on the aims of the experiment. What are they trying to do in this experiment, so that we can try to do the same thing using Python. Mind you, a computer programming language is just a tool for you to talk to your computer so that you can actually give it instructions. So the aims of the experiment, as you can see, there are 3 of them. One is to introduce you to the Python. In this case, I'm trying to introduce you to the Python 3 interpreter, and also a Jupyter notebook. And also to make use of Python 3 expressions and something called control statements. There's a misspelling there, so I'm trying to do that. So if you want to change something, you double click on the cell, control statements. Now you notice something here. This is one line which I have activated, a cell. We call that cells, and there are 2 types of cells. There are cells which you use for making notes, like in this case, I'm adding a title, experiment 1, then Python 3 basics. That's how I've done it. You can double click there, then you see something like that. Then there's the aim, I'm adding the aim. Then there's these objectives of the experiment, and that's how you actually add the objectives of the experiment. Then you run that, and it gives you that. So basically that's what it looks like. So what are we trying to do during the course of this experiment? So in this experiment, the first thing exercise we want to do is to see how you can run a Python program. How do you run a Python program, basically? And also, how do you store your Python program in a file so that you can run it later or on some other computer? How do you do that? Okay, so exercise 1, executing a Python 3 program. So I am going to be actively doing some stuff here. Once I'm done here, okay, I'm going to show you how it's done, how you do it on this side. Once I've shown you how it's done on this side, I am going to send you this same thing. Then you do it on your end. Okay? You do it, you run, you fill up the stuff, you do it on your end. Then after you do it on your end, you send back the notebook with your name. So you have to change the name of the notebook, but you have to include your name as well. Have we been joined by other people? Okay, so it looks like we're just the 2 of us, 3 of us. So fine. So we push forward. So basically, that's what the objective is here. So first of all, the first thing I'm going to do, I'm going to restart and clear outputs, or the output which has been produced. Okay. So the first exercise says, in this exercise, you're going to execute a Python 3 program using Jupyter Notebook that prints out the string hello world using the built-in print function. So basically here, that's the instructions. So the thing for the instructions. And what is the instruction? The instruction is to print hello world using the print function. Okay, so there are two ways of doing. When you're working with Python, Python allows you to write your programs or do your stuff in two ways. One, the first way which you're going to use, the first approach you're going to use is something called the interactive approach. Okay, where you write something, you run it, you see the result. So in this case, for us to print the string hello world using the function print, so we say print PIT like that, then there, then inside there, because it is a function, you give it a string hello world like that. Okay, so that's what you do. This is the interactive way of running a Python program. So you say print in this one, as you can see here on the cell here, the type of cell is a code cell. So in the code cell, that is where you write your Python code. When you run that, when you click on run, you see that it prints out hello world. So basically, you have just run your first Python program of this lab, hello world, and that's what you've done that. Okay. However, that is the interactive way of doing things. You type some commands, then you click run, then you get the result. There is another way where you actually store your files, your commands in a file so that you can actually use them later somewhere else. And that's what I'm going to show using the same thing. First of all, I need to close this. Just a minute. I need to make sure also that the file we're trying to create does not exist. So I need to remove any copies of it on my hard drive where this thing is stored. Are we clear with what we have done so far? Are we clear with the print function and how we use it to?
Yes, sir.
Okay, that's fine. That's good.
Yes, that's
All
right.
right. Robbie, I need you to use your mic. Yes, your microphone instead of using sending me text. Okay. Just a minute. I'm trying to open something. Okay. So there is this tab here. When you're opening a Jupyter notebook, so how do we actually get this print function? How do we put it in a file? So basically, when you're opening a Jupyter notebook, there is this tab next to, there's this one, the one which is active, as you can see there. There is this other one here, the opens faced. When you run your Jupyter notebook, the tab which opens faced, this one. Okay, so something, okay, it's open just a bit. This one, what you're looking at right now, this is the home tab for Jupyter. Okay, it is where we call it home because it is where, in my case, when I open Jupyter, that's where I take it to. Okay, so the tab which opens faced is what's known as the home tab for Jupyter. So, and in this home tab, you see a list of things. There's a list of folders, some checkboxes this side. Okay, there's a list of folders and some checkboxes that side. Now I'm trying to see if there's a copy of that file I'm trying to create, because we need to create a certain file, and I'm trying to see if there's anything of it on this computer so that it doesn't give us any problems. Okay, so there's nothing. That and that. I want to delete that. So you can actually select stuff like that, like that. You can do a selection like that. Then, yeah. So basically, the name I want to. Okay, there's that one there. So if you select something like that, then you come up. Like in this case, you can come and delete it there. So you can, when you select something, there are a number of things you can do on top here. You can duplicate them, you can copy them, you can rename them, you can move them, you can download, view, edit, or delete. So basically, in this case, I want to delete that, throw it away. So I click on delete, that's out. So basically, for you to create a file, using this environment, you can create a file. For you to create a file or a Python program using this environment, what you do is you come to the home tab. Okay? In the home tab, you come here where there's new. I hope you can see my screen. You click on new, something is going to open up. Okay? After you click on new, the next, what we want to do is we want to open a text file. You click on text file here. So you click on text file, then another tab is going to open up, which is going to be your text file. Okay. So, in this text file, so basically this is what you end up having. Next, in this text file, there is this here, the name of the file. It says untitled 2.txt. That is not what we want as the name of the file, as you can see from here. So inside the text editor, to open a text file, click on the home tab for your Jupyter notebook. Next, click on the new button, then choose the type of file to open as text file. Inside text file editor, rename the text file from untitled, whatever it is, it's 2 in my case, because there's something else down there, to hello_world.py. So basically, I'm going to rename this guy, this titled thing. I'm going to double click it. When I double click it there, then this whole thing, rename file dialog box comes up. So I'll say, I will change the name to hello_world.py. So I changed the name to hello_world.py, and as you can see, the name changes to hello_world.py on top there. Okay. The next thing you do is, since you are doing an experiment and you have to make submissions, you probably kind of like need to give me your name. Type, you put a comment there saying name. So I'll say Gift Johnny. Then next, in your case, you put your name there. Say computer number, computer ID, whatever your computer number is, something like that. Then next, you put the course, so that is PHY. That 32. As you can see, these are comments. They will not be read, but I need to know, when you send me this thing, I need to know from whom it's coming from. Okay. Then next, experiment 1, experiment number. So basically experiment 1 there. Then comments, exercise 1. Okay. Then of course you can also put a date, what date you did the whole thing. Dates, today's date. The date today is 5 September 2020. Okay, so basically That is the whole thing about the information about your lab, your details. You can put them like that. So the next thing we want to do is the command, the print, because we want to run the print stuff. So you type here print, then open and close brackets, then inside say hello world, then you close like that. So basically that is the same print statement which you have like in the interactive part. Then after you do this, so basically there has to be a part. This whole thing here done here, I think can be done in either that way, or you can use I think you can use something called a dock screen, that like that, where you can, I think this should also be able to work. I'm not quite sure, but I'll try to see if it works and see which one actually works better than the other one. Okay. Course. And okay. So either of these, we'll see, but either of these I think should be able to work. But I'll see when I try to run which one actually works better than the other one. So after you do this, so basically the code is that one there. The print hello world is that one there. So you click on file. Then after I click on file, you click on save. So it has been saved, as you can see. Then next you come back to here. For you to run that program, you type this command, that command. So you type %run, then hello world. Hello world like that. So you run that. Oh, something has changed a bit. So the type of cell is supposed to be code cell. Okay. So if you run that, that's what you get. So now you're getting, so either way. So I think actually, I think this one is a better way. Let's move the other one. Yeah, there. So author, your ID, course code, experiments, exercise, the date. Experiments is what? Python basics. The exercise is executing a Python there. Executing a Python 3 program. So you save there, then you run it. So this stuff on top here, this is what's known as, this thing I've highlighted on top, that's what's known as the doc screen. Basically, those are the details of the person who wrote the program. The author of the program, you put your name, your course ID, you put your thing, course code, you put your thing, experiment, Python basics, exercise, executing one thing, then the date, then after that, you write the code like that. Okay. Then save it. And of course, down here, we run it. Okay. You might be asking me, but what's the point of you just following what I'm doing? The reason is, even when you're just following what somebody is doing, as you type these things, okay? As you type these things, you are actually learning. As you are typing, you are actually learning how to do these things. So, yes, you're going to follow the recording. When it becomes available, you follow the recording and you try to do the same things I have done. Okay? You try to do the same things I have done. Then once you do that, then you know, then you submit the thing. Okay? And basically that's how it's going to work. I will guide, then you try to repeat what I have done, so that you make sure if you have learned or you have mastered something. Any questions on how you put your Python program in a file? Do you have any questions? Any question?
I only have one question, sir.
Yes.
Yes. So you are saying we go for this other method of writing the comment?
Yes. No, the documentation is called doc screen.
Okay.
So yeah, so we go for this method. Okay.
Right.
Now, this same program we have written here, I'll open another tab, my thing, my desktop, home, there. I hope you're seeing that. I'll go to documents. Then I'll go to UNZA, where are you? There. Then the course material is there. And there. Then I'll go to computational stuff. So we say hello. Come in. So there it is. So that is our program we have just written there. It says hello underscore world.py. So you can open this. It's a text file. So you can open it in any text editor. So I open with text editor there. So there it is. It was opened. And you can see exactly the things we did. So there you've got author, that's my name, computer number there, course code there, experiment, Python basics, exercise 1, executing a Python program, the date, like that. Then line number 10, print hello. So when this same text file, you can get this text file and run it on a different computer. It's going to run, no problems. That is the advantage of when you have once you have got all your codes running properly, then you get those codes, you put them in a file so that you can use that file anytime. Okay, so basically that's what the whole thing ends up with, like. Okay, all right. So basically that's those are the steps. The same thing, we ran it directly using the notebook, using the code cell. We said print hello, then it ran, it gave us the print hello there. There, print hello, it ran, get the print hello there. But we also had the option of opening a text file. That one, we open that text file. Then we put in you put in your details, the names, your ID, your course code, the experiment number, what experiment you're doing, the date on which you did the stuff. Then you put in at the end, at the bottom, you put in that command, say print hello. Then when that thing was saved, Then what did we do? We came down here, we ran it using %run, then hello world. This %run is a feature of the Jupyter notebook. Okay, %run is a feature of the Jupyter notebook. So you can run your program in a notebook like this, in a Jupyter notebook. If you don't want to run your program in a Jupyter notebook, then you can open something called a terminal. Open a new tab for the terminal. Okay, let me just open a new terminal. Open a terminal session, a new one. Start from scratch. So ls, like that. So I start changing directories to where my thing is. So I say it's my document cd. This part is not Python, but it's Linux. Cd ls cd change directory. So I'm telling the terminal to say I want to go into the documents folder. So I get into the documents folder. I do ls. There's a lot of stuff there. Where I want to go to is this one, UNZA. Okay. So what do I do? So I say cd UNZA, it finishes up, I enter that, then ls, I list things that are there. So where I'm trying to go to the PHY 3032. So I do another cd PHY 3032, then I do ls. I have got stuff like that. Then there's a folder called Jupyter Notebooks there. I say cd Jupyter Notebooks. I enter that. Then I say ls. Now, in these Jupyter Notebooks, the file I'm interested in is this one. Where is that? This is the file I'm interested in. That is our file which I've just created. That's the one I'm interested in. So if I have to run that file using the terminal, so I will type Python 3, then hello.py. When I do that, then I run. I type enter, then it just prints out whatever, it runs whatever commands are in that file. And the command which is that file is hello world, to print out hello world. Okay, so you can run once you have your commands in a file like hello.world.py, you have an option of how you run your things. You can either run your commands through the Jupyter Notebook using %run, then the name of the file without the extension. Python is going to know you're looking for this kind of Python file. Or if you're using the terminal, you can say Python 3, then hello world, then .py. So you have to be specific about which file you're actually trying to run. So basically, that's how that bit works. Okay. This other thing is Linux. I'm trying to, I think maybe sometime next year or something, I'll try to create a course for Linux, but for now it's Python. So basically, let's try to stick to mostly we're going to do our things in the notebook, not in the terminal. Okay. So I go back to where we are here. Are we clear so far to say when it comes to Python, you can either run your programs like this, print hello world in a cell, or you can put your program in a file, then you run it like this. Are we clear about this part? And how we go about doing that? Okay.
Yes, sir.
All right, good. Next, we have experiment number 2. Experiment number 2, it talks about statements and expressions. Now, for you to do any meaningful programming, you need some statements and also you need some expressions. Okay. And in science and mathematics, basically, these things have to be there. Mathematics. I think there's an E missing there. Yeah, mathematics. Basically, you have to do these things like that. So in Python, we're going to see how we're going to do this using Python. And we'll do that by trying to solve a problem which we have been given in our lab manual for us to do. So the problem is the position, velocity, and acceleration of a body undergoing simple harmonic motion are calculated using using the equations given below. So the first equation is position. If you double click on these things, you can see how I type this stuff. How do you type an equation basically? So you begin with something called this is borrowed from another kind of computer language for typing called LaTeX. So basically you start with begin equation. So you're telling Python the notebook you want to start writing an equation. So you backslash begin, then inside these brackets you say equation. So the computer knows, okay, fine, you want to start writing an equation. Then there has to be something also which says end equation. You have ended writing your equation. Then in between here you type your equation, which is basically that. So you've got math rm position, then there's a, then there's this backslash sign, then there's something like there, then there's pi, you can guess that is pi, then p, then epsilon, and basically that's how that whole thing works out. So you can actually see how the stuff is done. And that's how you, in physics and mathematics, basically, you use this language called LaTeX to type mathematics equations. So basically, that's how your mathematics equations are going to be typed, and they just come out nice and neat and looking like that. So what we are supposed to do is write a Python program, Python 3 program that calculates the position, the velocity, and acceleration at time t equals to 8.2 seconds using the values pi equals to 3.159 that, and epsilon equals to that, then a equals to that, a being the amplitude. And from what I sent you, they are instructions on how to do the same stuff in Fortran. But however, those instructions for us to do the same stuff, carry out the same task in Python, we will kind of have to modify things a bit. Okay, the first modification you're going to make is in Python. If you look at the thing I sent you, the first instruction. So first, basically, so right here, say instructions. So you can also see how things are done, so that you can actually do your lab. If you want to do your lab, you can actually do it ahead of time. So I change my code like that. So instructions, the first instruction says instructions like that. So the first one says declare. Okay, the first one says declare as an integer constant, epsilon as an integer constant, pi and a as real constants. The problem here is in Python you are not allowed to declare things without giving them values. Okay, so here it says declare epsilon as an integer constant, pi and a as real constants, position, velocity, acceleration, and time as real variables. Then initiate time to 8.6. Write an expression for position, velocity, acceleration. Print the values of time, position, velocity, and acceleration. In Python, you're not allowed to declare things without declare variables or create variables without giving them values. So our instruction is going to change. We are going to create these variables pi, epsilon, and a, and at the same time as we're creating them, we give them the value. That's the only way Python is going to accept. As I'm going to show, I'll try to create a variable pi. So create variable pi. Like that. Okay? That is the instruction, create a variable pi. So if I do the following like that, like the way it's supposed to be done in other languages, I do that. Python refuses. Okay? It tells you, so there's a problem here. This pi you're talking about hasn't been given a value. So Python does not allow you to create variables without giving them values. So when you create a variable like pi, you have to give it a value. Okay? So our instruction is going to change it to say, create variable pi and initialize it to the value 3.1415.925. So let me just check, counter check everything is 3.14, 15, 92, 65. Okay, like that. So the only acceptable thing to Python would be you create your pi, then you give it a value at the same time. So you create it and you give it a value at the same time, like that. Now there's no problem. Okay? Has everything worked out? I can say print variable. I changed the thing here. Say print variable pi. I can do that to see if things have actually worked out, if you don't trust what you've done. So I'll say print pi. If you say print pi, there it is. So that's actually showing you that the variable pi has been successfully stored in the number 3.1415926 has been successfully stored in the variable pi. So we're going to do a similar thing for these other ones. So we have epsilon, you've got a. So for epsilon, I'll copy that, then I'll move it down. So create a variable epsilon, epsilon, get a variable epsilon and initiate it to the value of 0, like that. So I'll say epsilon is equals to 0, like that. Then if I want to print again, it's your notebook. You're doing this because you want to make sure everything is in order. It's interactive, so you can see if things are actually happening according to what you imagine things are supposed to happen. So I print AP epsilon. There. So that also has been stored. The next thing we need to store is A. A is the amplitude. Okay. So I was saying, I'll copy that. I'll move it down. Create variable amplitudes. A. Amplitude A, and initiate to I think, let me do this. Amplitude is more meaningful, like that, and initiate to a value of 2.5. So there. So here I say amplitude amplitude is given a value of 2.5, like that. Then I can also print the amplitude. So I can say print amplitude. Like that. Okay, so basically what you've done so far, in Python's way of doing things, we have managed to store the number 3.1415926 in the variable pi, and we have proof for that. We printed out that. We printed pi, then you saw it worked. Then epsilon, that we stored it in 0. We stored it in 0. That we got that, and we printed. We got that. Amplitude is 2.5. That, and we did that. Okay. The other thing is the time. The time. Okay. Okay. Let me make a change a bit. Epsilon. Let me do this. Let me write the epsilon outside so that we can epsilon. Then if we can store it as E, I think like that. Let's do it as capital. I don't know if it's convenient. It's either, which one do you think is better? Epsilon, the weight, or the letter E? The weight or the letter E? Okay, so then we stick the weight.
The letter E.
The letter E? Or epsilon? The weight?
I think the letter is better.
Okay. So
the letter E.
Okay, so we change there. Like that. And print the variable epsilon. So epsilon. Okay, then the amplitude. So the amplitude means we have to store it as A also. If we're going to follow that convention, amplitude A. Like that. So here, like that. Variable amplitude. Then okay, there. The next thing we need to do is so basically we have put the value for epsilon in E, we have put the value for pi in pi, we have put the value for A in A. The other things, position, velocity, and acceleration, we cannot declare them yet because Python only allows us to do such things when you are ready to actually put something in a particular variable. So if you are not yet ready, you can't use something. Python only allows you to do something, create a variable when you are actually using it, where you're actually using it. Okay. Next, time. So comment for time, it says we need to put the time as 2.8. So here I say initialize, create a variable for time. That variable is going to be t, and initialize it to 8.2. 8.2 seconds. There. So we say t, that's our variable. Then we store in there 8.2 seconds, like that. So that's done. Then you can print the variable for copy that. Print the variable for time. T. So print T. There you have your 8 point something there. So the other one, so you print the variable for time, print the variable for amplitude. I'm supposed to put for amplitude. There, it's better English. For amplitude A, create a variable for amplitude A and initialize the value of that. Print the variable epsilon. Okay. Print the variable for epsilon E. Create a variable for epsilon that's print the variable that. Okay, basically that part is okay. So we have created 4 pieces of information, and each of those pieces of information has got a value it is holding. That is a row in Python. Okay. If you create a new piece of information, make sure that piece of information is holding something. You can't create pieces of information which don't hold values. Okay. So the next bit we have to do now is says write expressions for position, velocity, and acceleration. Now, for you to write an expression like this, an expression for position, velocity, and acceleration, yes, position is just a variable, velocity is just a variable, okay, acceleration is just a variable. However, you have got the other parts which you don't know yet. There is a sign, there is cos and sine, okay. Cos and sine are mathematical functions, okay. Cos and sine are mathematical functions, and Python at the moment, if you just say sine something, let's say sine whatever we have. If we say sine, let's say write an expression for position. Here, if I say write an expression for position, so we're going to say write. I'll show what's going to happen. Write an expression for variable position. Okay, so if we do that, markdown. So I say if I do that, position is equals to, what's the first thing we have there? You have A sine. Okay, so A is the amplitude, so we write A, then times, we say sine, then inside the sine there is a value of pi. There's pi times t plus epsilon. So inside there we say pi times t, then plus e. If we do this, yeah, it looks like everything is okay, but everything is not okay, because as you can clearly see, when we do that, Python protests about this, the sign. It tells you, boss, I don't know what this is. Can you help me with that? Because at the moment, Python does not understand what SIN is. It doesn't understand that it's a sine function. So you need to help Python to understand that sine is a sine function, and the sine is a function which is found in something called a module, okay, a math module. So before you write the expression for position, what you actually need to do before you do that you need to tell Python, say, I want you to go and look in this particular file and get this sine function and get this cosine function. Exactly. Which means we need to, that's now what's something called an import. We need to do an import where you're going to get the sine function. You tell Python to go and get the sine function and the cosine function from somewhere on the computer. Okay? So otherwise our thing is not going to work. So we have to put an instruction here. So say import sine and cosine. So import sine, because we need sine and cosine. Import sine and cosine. Functions from math module. So there's a module called math. It's a library which contains a collection of useful mathematical functions. Among those functions is sine and cosine. So how do you import sine and cosine? So you say from math import sine and cosine, like that. That's how you do it. So you say from math import sine and cosine. Now when you do this, then you try to rerun this. Now Python understands what sin means, that you're actually talking about a sine function. Now when you run this, there's no problem. Okay, so the problem is fixed by you doing that import thing. Okay, then next you print out the position. So I copy that. Print out position. Let's print out the variable position. So I say print position, and there I have the position. So Python has worked out using the pi, the t, and e. Pi is a number in radians. Time is in seconds. Then that, using this whole thing here, you multiply, you get some number. In our normal, when we're doing our normal mathematics, our calculators use degrees, but your calculators can also use radians. However, when it comes to computers, you do not have an option of changing between degrees and radians, because trigonometric functions, when it comes to computers, they only work with radians. So if you've got 90 degrees, you have to change that 90 degrees into radians. So it becomes pi divided by 2, or 0.5 pi. So in this case, everything here, if you're going to do something with sine, everything in here, everything in that sine thing needs to be in radians. So pi times t, pi is already in radians. You can't multiply 90 degrees times time. No, that's not how it works. Okay, say 90 degrees times time. You can only multiply pi times time. Radians, angles in radians can be multiplied by other physical quantities, and that's what the computer accepts. Are we happy so far? So far, are we good? On what we are doing?
Yes, we are following.
Okay. So it's very, very important that you are following what this is, what I'm doing here. Okay? So that you're also able to do it. Because when we finish this, what I'm going to do is, I am going to put on your Moodle, I'm going to put the notebook, but without the codes. Okay? I'm going to put the notebooks with all the instructions. Do this, do that, do this, do this, do this, do that. Like so, you should be able to see, understand exactly what we are doing. Okay? So next, bits, and you're just following exactly what I'm doing, which means most of the time this should be a free 15 months. Okay, as long as you can follow, then you repeat the same things you did. As for me, you see, when after spending time with the Chinese, if you can repeat what something did to the latter, then I know you've learned something. You might not be able to understand exactly what's going on, but if you can repeat instructions, then you're learning. Okay, the more you repeat instructions, the more you learn. That's why those notebooks which are on Moodle, where I keep on telling you, run them over and download them and run them over and over and over and over. The more times you do that, if you have run that notebook 50 times, you should be able to know everything which is there. If you keep on reading, then the things stick. So basically that's what the whole thing is here. Repetition. As you repeat something, you understand why something works like that. Okay. Similarly, write an expression for velocity. So I copy that there. You can see what I'm doing. I'm copying something because I don't want to write too many things. Okay, so I'm write an expression for position. Instead of position there, I'll put velocity. Then I paste it, then I move it down. Like that. So I change here from position, I put velocity. Okay, then I run that. Okay, now it's velocity. So now I'm working on the velocity. So velocity is equals to, what is the thing for velocity? What's the formula for velocity? How do you cut the velocity? It's A times pi. So I start with A times pi, then times what comes next? Cos. Then inside, so cos times cos. There's no harm in doing things one bits. Then inside that, then you have got the pi times t, then plus e, like that. Now Python will not complain about the cos because we gave out an instruction here to import the function cos from the math module. So when you do that, that runs. Then we come here, we copy that bit, copy it, then paste it, then move it down. We say print the variable velocity, like that. Then you say print velocity. There. That's how fast it's moving. Velocity. Okay. Okay. Are we clear with this? Up to this point? So you work out something, then the next line you actually see it. You work out something, the next line you actually see it. Like that. Okay.
Yes, sir.
Yeah, good. Then there is also acceleration. So I copy this, write an expression for the variable acceleration. So just go copy there, paste, then I move it down. And I change there, that one, I change it to acceleration. Then I say here acceleration is equals to, look up the formula for acceleration. There is what? There's minus, then there's a, then pi to the power 2. So I'll start with that bit. So there's minus a times pi, then to the power, you want to raise something to the power, use two stars to the power 2, then after that, times. So that is the front part, then the inside part, no, it's supposed to be cos, not sine. Sorry, it's supposed to be sine, I believe. Yeah, it's supposed to be sine. Yeah, that's supposed to be sine. So inside we get here sine. Then inside that you got pi times t, then plus e, like that. So you have got the minus here, then there's the amplitude times pi to the power 2 times sine pi times t plus e. Then run that. Python doesn't complain. It's okay. Looks like everything follows the rules. Then we print out what the value of acceleration is. So you can say print acceleration, and you get your acceleration as minus 14.5 something 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 something. Okay, with so many decimal places. Yeah. So print the value for print the variable, print the value. Let me say print the value for acceleration. Print the value for acceleration for variable acceleration. Okay, that. There. Also. Okay. There. Okay, so we have managed to do what you've been told, right? Right? Yeah, we've managed to do what we've been told. Print the values of time, position, velocity, and acceleration. We have actually done that. So basically, that bit has been done. And that's how this whole thing works. So it's not kind of like, yeah. So at t equals to 8.0, 8.2. So these are the values. So basically, this whole thing kind of like been done right then. Now, you will notice something here. One, there's too much repetition in the print things. We are printing things all over the place, trying to confirm if things have been done the way we want them to be. So basically, that is the benefit. Yes, there's a bit of repetition, but it gives us the assurance that whatever we are trying to do is actually being done that way. Okay. Then two, the codes are in different lines. Okay. The codes are in different lines. Pi is alone there. Epsilon here. Amplitude, the time. Okay. Then there is you also print the things there. But if you knew that the whole thing is going to work the way it's supposed to work, there is really no need to print anything really. Then you've got this line here from math, import sine and cosine, it's on its own. Then this expression, right expression for that, that's on its own. Then right expression for velocity, that's on its own. Then you print out the velocity, right expression for acceleration on its own. Then you print out the things. We can actually put all these things in one cell, as I'm going to show. Yes, you can actually put all these things in one cell. Okay. So, what was the first instruction here? The first instruction is create a variable. This one, create a variable pi and assign it to that. I'll copy that, but I'll put it as a comment. There. So I do that. I'll say comment, then that. Create a variable pi and assign it to the value that. So after I do that, then I get this. I copy that. copy. Then I put it there. Okay. The next, where do I come? Which other thing they were supposed to create? Here. Create the variable epsilon and store a value of that. So I copy that. Store it as a comment. Then so once we are sure that our stuff actually works the way we want it to work, then we can copy everything, put it in one cell, like that. Okay? The next, what was the next instruction? This one, right? Amplitude A. Let's copy that. That. Then I come here. I copy that. There. The next bit is time, right? This one. I copy that. There. Then so you can see I'm ignoring the print statements because I'm sure what I'm doing, those work. If they don't work, then Python is going to protest. So I'm just putting the important stuff, the print stuff, to make sure something has happened. I'm just ignoring those. Okay. Then I come here, import from math module. That one. Right. And that's a good thing about these cells. They are flexible. As you add stuff to it, it becomes bigger and bigger and bigger so that it can accommodate things. Paste. There. Then it says write an expression, position. Then I copy the expression I wrote. The next, write an expression for velocity. Like that. So even here, even in this cell, what I'm going to do is I'll remove these codes. I'll leave the comments so that you come and fill in with the, you understand? You fill in with, you follow the instructions, right? Pi, something like that. So like that. Okay. So you put those things, t equals to 8.0, a equals to 2.5, e equals to 0, pi equals to that. Okay. You follow the instructions like that. Then after that, because I'm not going to give you this actual thing, okay? There's going to be a recording. You can watch the video recording, then you follow through. As long as you reproduce what we have done, that's fine by me. Okay. Then write an expression for acceleration. That. Okay. Next, they tell us to print the values of time, position, velocity, acceleration. See, print the values for time, print the values, position. I don't think because we already know the time, really. So we don't need to know the time. Okay, fine. Give it the instructions. Velocity. Acceleration. So I'm going to do something different here. So we're going to say print. Then inside the print, we're going to say time, like that. Then that. Then space seconds. Then we're going to say format. This is from the lesson on strings. We'll say T there. So you should print time in seconds. Then here, position. So say print. Let's hope it's not in meters, definitely. I think it's in seconds. In centimeters. Say position. Meters. Position. Then here, so print. Velocity. Meters per second. Velocity. I know what I think. I'm sure it's right. But I'll try. Oh, acceleration. I hope it works. Print. Meters per second. I don't know if it's going to understand, but I'll see. I'm just trying. Then you run that. What is it? Oh, okay. Yeah. Okay. So this one, yes, meters. Okay. I'll just say square seconds. Square sec. Like that. Okay. So we get our things like that. So basically the time is 2.8 seconds. The position is 1 point something 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 something. Then the velocity is something 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 something. Then there's that. And you can also see some extent that the output is not very good because of the large number of decimal places, and that's not really something I don't think we need. Okay? So apart from doing that, we can also go back here. We can also do some gymnastics. So we can say, okay, fine. What kind of thing is this? Let's put a dot there, a semicolon, to specify it. Say we want, it's a float, okay? But how many decimal places do you want it to? We want it only up to 1 decimal place. That's fine, okay? Like in the case of this one, it's fine. But this other one here, we can decide how many decimal places we want our position to be. Maybe we want only up to 2 decimal places. So we can say that. So that's a specifier for how we want to specify the position. Okay, that, then dot 2 decimal places, then F. If you do that, that's what you get. You get 1.47 meters. So that's much better, a much better output. But this one here doesn't say, so we need to actually also say something there, just one. So we have got our time as 8.2 seconds. You've got a position is 1.47 meters. You most likely also want your velocity only to 2 decimal places. So you would say that. So dot 2 F. I'm not really going to teach this, I can explain, but it's there in your notes under strings and formatting strings. Okay. That, so that's how it changes. The same thing can be done here. That. Dot 2 F. Like that. Okay. So, do we have any questions? So this is pretty much our, all these things we've done. All these things we've done up here. Or under exercise 2. All these things we've done up here. Put them in different lines, checking if everything is okay. You can do that, yes, to make sure whatever you're doing is correct. But after you have done that, you actually want to make a Python program, right? So for you to make a Python program, you actually get all these things, you put it in one cell. Then you see if things are working out fine, like they're supposed to work out, okay? This is good, like here. Then when you do this, you get this stuff, all these things here, you copy them, okay? You copy all this stuff, then you put it in a text file, a program file, okay? You put it in a program file which you're going to call simple harmonic oscillator, okay? So, how do you create a program file? We already have one here, that's fine, but for the benefit of those who are not here, so you come here, you come to your home tab for Jupyter, where it's written Jupyter here. This is a home tab. You come to your home tab, then you click here on new. Then you click on text file. When you click on text file, you get something like this. Then our program is harmonic oscillator. So we'll change it here. I'll say simple harmonic oscillator. Dot P1. Simple harmonic oscillator P1. Then I save that. So basically that is what my program is going to be called. Simple harmonic oscillator P1. The next thing I do is there is this bit. This one. So I want to, because you have to submit this to me, right? So you click on the there. You create your doc screen like that. Then in this case, since I already have something, I copy that, then I put it here. But now the experiment is experiment number exercise. Okay, that's fine. But the exercise is exercise 2. And exercise 2 is what? Here. Statements and expressions. I copy that. I come there. I put there. So that's there. Okay, I can save a bit. Okay, so that's okay. Then down here, I come all these things in one cell, all this stuff, this stuff here, this stuff here. I copy all this. Okay. And I put it here. There. I put it here. Yeah. So I have created a Python program file. So I copy that stuff, which is, I'm sure is going to work. Okay. Then I put it here in this simple harmonic oscillator file. Sorry? Oh, the last part has not been copied. Okay. So I need to go back and pick the last part. Yeah. The acceleration part. There. Then I save. Okay. After saving, now, if you are not sure if something has happened or not, you come into your folder where you keep your programs. Is there something called simple harmonic oscillator now? SP, something, SP. After P, that's the A's. There it is. Simple harmonic oscillator, the pure. If I open that using a text editor, it's quite a small thing, but you can see everything we have done. There it is. Okay. So now that we are happy with this, now you can't run the actual text file. You have to run it from somewhere. Okay. So how do you run that now as a program? So it's here. So how do you run that? You say %run simple harmonic, but you have to remove the PY. So %run simple harmonic stuff. So when you do that and you run it there, so the Jupyter notebook just goes to, it looks for a file, a Python file called simple harmonic oscillator. Then once it finds the file, it carries out all the instructions that file. And among those instructions that file is to print out the time, print out the velocity, print out the time to one decimal point, print out the position to 2 decimal places, print out the velocity to 2 decimal places, print out the acceleration to 2 decimal places, and the units. That is one option in which you can actually, so that's why I like the Jupyter notebook. The Jupyter notebook right away allows you to test your codes. As you are running your commands, you can see what the output is. Okay, as you run your command, you see what your output is. Once you are happy with some commands, you select those commands like we did here, you put them together, then you run them again. Okay, things are good. Then if you're happy with this, you get these commands, you put them, you store them in a text file. Then you can carry this text file to any computer, then you can run the same stuff there. You just say like that. If that computer does not have Jupyter notebook, then you have to run it through the terminal. So you go to the terminal, like in this case, then you want to see if that thing is there, alias there. So where is our stuff? There it is. Simple harmonic oscillator .py. So you say Python 3 simple harmonic oscillator.py. Run that. There. The time is 0 point start, position is start, your velocity is start, your acceleration is start. So you can actually run your that's the advantage of having your codes in a program file. You can use different tools to run these. Okay? You can use different tools to run these. Your notebook also comes with something called spyder. Have you seen that? Have you noticed that program? Your notebook also comes with something called spyder. Spyder means S is for scientific in spyder. The PY is for Python. Then the DER is the D is for development. Then the ER is environment. Scientific Python development environment. So you can actually do spyder. I can say, let me see if it's going to run here. Is that spyder here? Like that. Spyder. Spyder comes with your Jupyter notebook. Okay. So something is happening. Okay, there's spyder is starting. Spyder 3. And you notice something. We're using Jupyter notebook, Anaconda, there's spyder. But it's not really spider, but the icon is for a spider. You can see the picture, right? Yeah. So, like, yeah. So you can do that. So apart from using, you have a choice. You use your Jupyter notebook, then you use the texting, then spyder is going to, where is it? Let it open. Okay, starting somewhere. All right, here it is. Okay, so this is spyder, scientific Python development environment. Okay, so I close here. Okay, there. Then I open it. There's an open there. Okay, open file. So I click on that open thing there. Then I go to where my stuff is. My Python stuff is contained. It's contained in documents. Then under documents, there's UNZA there. Under UNZA, there is P3 something there. Then there's Jupyter notebooks there. Then under Jupyter notebooks, what I'm looking for is something called simple harmonic oscillator, right? There, that file. I open it. When I open it, here it is. Okay, author. It's not very clear. It has got its own colors, but things are kind of like, but basically it's the same thing. Okay. Then in spyder here, I don't. How do I zoom stuff? How do I say? Let me see. Memory column stuff. Let me see. Run it from there. Yeah, run. So when I run it, I click on run. You can see in this here. Okay, the time, the position, the velocity, the acceleration. You can also write your Python programs. If you don't want to write your Python programs in Jupyter Notebook, you can write your Python programs in spyder. Then you run them like that, then you see your thing like that there. But you have to keep on, as you keep on writing your stuff, you have to keep on that. Then here, you can also kind of like, this is like it's like the notebook, but it's a kind of like a primitive version of because the notebook lines are kind of more advanced. Okay, but you still get a primitive thing there, like on 2 there. I can say, like the command we started with, I can say print. The inside there, I say hello. Hello world. Then I enter, it prints out hello world. Yeah. So this is also part of your jupyter. Spyder is also part of your jupyter. So if there is need now, maybe you want to collect your ideas, the jupyter, I like it because it allows you to one line, see what the output is, one after the other. And also you can easily type out the instructions, then try to follow those instructions. So the jupyter is good for actually learning how to do something. So that is the advantage of having your program in a file. When you've got a program in a file, that program can be accessed by different applications. Like Jupyter, like the software, we have accessed the same file using 3 different applications. We have accessed it using Jupyter, this side here. We accessed it using Jupyter. We accessed it using the terminal earlier here. Then after the terminal, we ran spyder. That is the advantage of putting things in the file. You can also carry the file, or you can send someone the file. You guys can run it using whatever they kind of like use, whatever they are. Okay. Is that clear? Are we clear?
Yes, sir.
Okay. I really don't know about the other people why they have decided not to show up, because clearly life is going to become very difficult for them. Yeah, because they are missing out on critical things on how we intend to approach this whole thing. Okay, so there's another experiment. Let's see, in your list of things you're supposed to do, okay, yeah, that says exercise 3, list directed input output. Okay, so that's what you're going to do. Do you guys have your lab manuals? Did you ever get your lab manuals? From Mr. Wansa? George Mons? No, so which means I have to continue scanning this and sending them to you. Okay, so exercise 3, I'm going to do a bit of typing. Then after we do a bit of typing, that also allows you to see actually how this whole thing, how I'm doing this. Okay, then after we do the typing, then we write our beautiful program and see what it does. Okay, so I'll start. The first thing is I'm not writing computer code, so I'm going to do a bit of typing. So I change the type of cell. I change it to Markdown, and you see there's a change there. Okay, so I want to put a title. That's 3. Is it 3 or 2? Yeah, there. So that will be exercise 3. And I put it there. It says list directed input output. Okay, then there's some stuff I need to type. I'm going to do that. So inputs and output. Facilities are features through which programmer and program communicates. In this exercise, So in this exercise, you are going to be entering information needed by the program through the something called standard input device. Standard input device is just the keyboard. Okay, and print the results. Print the results from the program to the standard output device, which is just the screen. So write a program. Write a program in Python 3 that will output that will prompt you to enter the following information from the keyboard. So basically, this is an exercise in getting information from the keyboard. How do you get information from the keyboard? So the information we are looking for is your names, that is surname and first name, your birth year, your computer number. Once you give this information, the program should do the following. The program should then display the above information on the screen in a sentence. Which reads something like your names are John Wanda. You are 18 years old, and your computer number is 1201223. 2, 3, 4. Yeah, so basically that's what you want to do. So I hope you have seen how I've done the typing. So there, so that's what we basically computer number is, not C. So it's an opportunity for you to also. So basically, if you want to enter information like this in a notebook, like the way we have done it like this, you want to enter information like this, you need to change the cell to markdown. Okay, then you can enter your heading, then you type your stuff, the stuff you want to type, then you run that, and it actually comes out like that, which is quite clean. So what are the instructions? Now the instructions, again, remember the instructions are in a different programming language, and Python really doesn't work like that. Instructions. Okay, so what are the instructions? So the first instruction says declare variables for name, for the surname, first name, and computer number as characters, variables of specific length. Python does not allow you to declare something without you giving it a number, without you giving it a value. And also at the same time, Python on its own, it determines, here it says variables as characters of a specific length, which is a specific size. Python has got no, it's quite intelligent on its own to determine the size of whatever you've entered. The other thing here is we are trying to get things from the keyboard. It's possible in Python to get things from the keyboard. Okay? Once you get something from the keyboard, then you can store it later in a variable like surname. Okay? How do you get something from a keyboard? How do you prompt somebody to enter specific information in Python from a keyboard? For example, first name. So how are we going to ask the person? How are we going to ask the person to enter a first name? Huh? How do we ask a person to enter their first name so that when they enter their surname, we can actually collect that information from the keyboard, then we store it somewhere? How are we going to do that? So instruction is prompt or ask the user to enter. How are we going to do this? Enter their surname. Yes? What do we use?
We declare the variable first name equals or assign the name.
No. We want to get the name from the keyboard so that the person types the name. Using what? Yes. So Limpo here is saying that we have to use the input function. So what happens when you use input? So you say input, then inside input, what are we going to put inside input? What do we put? Okay, so Limpo says enter surname. Enter surname or your surname? Enter your surname. Okay, so when you do this, enter your surname. What does Python do? Then you run that. If you click on run, that's what Python does. It displays a dialog box which says enter your surname. So if you're looking for information from a person, okay, you're looking for information from a person, then that's how you do it. So that person, wherever they are, they enter the information through the keyboard, then that's how you do it. So Python is blinking there and it's looking for the surname. So what do we enter the surname? What do we enter? Okay, let's enter Banda, like in the example. So enter Banda. After you type Banda, press enter. Then you notice that whatever you entered as Banda, Python, right? It displays it on the next line, okay, as output. So basically, with input, you can prompt a person to enter their surname. But what we want to do is, we want the person to enter their surname. Then after they enter their surname, we want to store it in a variable called surname. Okay? Basically, that's what we want to do. So copy that bit. So ask the user to enter their surname, and we say and store it in variable. Store it in variable surname. So we create a variable called surname where we're going to store whatever surname the person has entered. Okay, like that. So how are we going to do this? How do we do this? How do we ask the person for their surname? Then after that, the moment they enter their surname, we store it in a variable called surname. How do we do that?
Surname is equal to...
Yeah, so surname, the variable in which we want to store things, like that. Okay, so if the variable in which you want to store something, you put it inside. Then we know this part. This part is carried out first. So Python is going to do this part first, the input thing. It's going to display. We need to wait for you to enter your name, whatever name you want to do. Then after you enter the name, it's going to store that name in surname. So in this case here, we click that. It says, okay, enter surname. So I say, okay, fine, surname is Banda. Okay, so nothing happens. Now it's no longer printing out this Banda here. Okay, Python doesn't print out the Banda anymore. But that doesn't mean that nothing happened, because instead of displaying the Banda, that Banda has been stored in this variable surname. So if we say print variable surname, I change to a markdown. That. So if I say print like that, surname, you see that surname has actually been successfully stored in Banda. Okay, so basically that's how you get information from the keyboard, using the input function. There is no other way. It's just the input thing. If you're going to get information from the keyboard, you have to use the input function. Okay, so next we need to ask the person for the first name, and we store that first name in a variable called first name. So copy that. So say ask the user to enter their first name. First name, and store it in a variable. The variable name is first. First name, like that. So how do we do that? So copy that. I put it there. Enter your first name. Like that. So you ask the person to enter their first name. So the first name is John. Okay, then you press enter. There it goes. Nothing happens, but that does not mean something did not happen. We print out first name. So print Get a John there. Okay? The next thing you're asking the person is what year were they born in? Okay. Birth year. Okay. So ask the user to enter their birth year. Birth year. And store it in a variable called birth year. Birth year. Okay, like that. So you ask the user to enter their birth year, then you store that in the variable called birth year. So birth year, inputs, enter your birth year. So they enter their birth year. When do you think this guy was born? Someone, it says 17, right? So someone who is 17 years old, when were they born? It says 18. So 18, 2020, they're born in 2002, right? Huh? Yes. 2002. So the birth year is 2002. Okay. Then birth year. So say print. Print birth year. There, 2002. Okay. The other thing we need to get is the person's computer number, right? So ask the person to enter the computer number. The UNZA computer number. And store it in a variable called computer number. That. So computer number. Input. Enter your UNZA computer number. Okay, so the computer number is 234, like that. So we have got all the pieces of information we need about this student using the input function and store that information securely. We can also print computer number to make sure everything is okay. Things have been done according to what we think have been done. So it's always important to check. Computer number. Like that. So you say print computer number. So there it is. So basically what we have done so far is if we go back to what we've done, we've got the name, the guy's surname here. We have stored the surname in variable surname, then it's Banda. We have got his first name. His first name is John there. We have stored the first name John. We've got his birth year. there, and we've printed it out, and you've got his computer number, and you've printed it out. Okay. However, we need to use the year the person was born, right? The birth year, and the year today, okay, to work out their age. Okay. So we create a variable this year. Create variable, because this year we can't use 2020 because next year the year will be different, right? Okay, so actually we can just ask the person to enter the year this year. Yeah. Ask the user for this year. We don't really need to ask the user. Create a variable this year. Okay. We can change that bit roughly by hand, that's okay. It's kind of like avoids a certain non-gun complexity. You can get the year from the computer. Okay? Maybe you should do that. You should try to do that. Okay, let me see. So if you get the year from the computer, it says from not sure. No. It's a bit tricky. Unless I have to look at something, but it's fine. Okay, just say this year. This year is 2020. Like that there. Okay? That's fine. It works. So now, if we try to do the following, this year minus birth year, so that we can get the age. Okay? Create a variable. Let me cut that. Okay, create a variable. So we create variable age, so that we want to get the age of this guy. Okay. And so we say age of this person is equals to this year minus birth year. What's going to happen here? If we do this, age is equals to this year minus birth year, what's going to happen? If I run this, Python complains. Say, I can't carry out this operation of age minus birth year. What is the reason? Because apparently Python seems to think there is an integer and there is a string. Okay? So which one is which between these two? Which one is an integer? Which one is a string? Because you can't subtract a number and a string. Okay? So we do the following. Down here, say check the data type of this year. What kind of thing is this year? How do we do that? By using what do we use to check the data type of a variable? Yes, the type. So say type this year. Type this year tells us this year is an int. Okay? So we do the same thing for birth year. Say type type Bethier tells us Bethier is a string. Okay? Why is it Bethier a string? We entered a number, but why is it a string? We entered a number. We entered 202. Here. Enter your Bethier. You entered 202. You didn't put it in quotation marks. But now Python is telling us that Bethier is a string. Why is that the case? Because of the input function. Okay, the reason is because the input function always stores whatever it gets from the keyboard as strings. Whether they are numbers or words, it always stores everything as strings. So, for our thing to actually work properly, we need to change, as we are trying to do this calculation of age, okay, we need to change the Bethier, which is a string, into an integer, right? So how do we do that? Using the what? Int function. Okay, so we're saying calculate the age. Calculate. Create age. Create age. Age variable age. Variable age. Variable age by casting. This is now called casting. Casting Bethier. Into an integer. Into an integer. So we say age is equals to this here minus int, then inside int, that's why you put Bethier like that. So when you do that, it works. Age is equals to this here minus int Bethier. So we're actually changing, we are making, we copy Bethier, the value which is there, the 202 string, then we change that string into a number, then we use it for the difference. Okay, now we can say print print variable age. So now you can say print age. Age. And now it works. Now we get our age as 18. Okay. So now we have got everything. Now we have got everything. The only thing now we need to do is print out that sentence. Okay. So how do we print out the sentence? So we create a string format for sentence. Okay. Or we're going to call it text. Create a string format. So create a string format called text or sentence. Sentence is better. Sentence. Which you're going to use for that purpose. So this sentence is going to read as follows. It's going to be sentence. Sentence is going to be the following. It's going to be a string. Okay. So this string should read. What does it say? Just a minute. Okay. So you read the following. Your names are So you should read your names are, so there should be the first name there. I'm putting a placeholder there. Then there should be your second name there. Names are that, then full stop. Then you are so many years old. Okay? And your computer number is and your computer number is something like that. Okay, so your names are something, your computer numbers is something like that. Okay, that's fine. But we know certain things to say. Here is supposed to be a string, right? It's supposed to be, so we can actually specify, say, no, we want a string here, so that there's no mistake. There is also supposed to be a string, right? Here is supposed to be age, right? So that's supposed to be a number, an integer. Then here is, at the end here, it's supposed to be a string, because the computer number is being stored as a string. So we have that like that. Excuse me. Let's go to settings. Okay. So you can actually print out the sentence, say print string format sentence. So we'll see what it looks like, so that you don't have to type the whole thing over and over and over again. Print string format sentence. So you can say print sentence. When you do that, that's what you get. Your names are a space, placeholder where you're going to put a string, then another placeholder you're going to put your another string. You are that placeholder you're going to put the years old, and your computer number is something like that. Okay. Now, for us to display the information which we have been given, we need to do the following. So to display the information, we need to say so display print final, print full string format with print string format with format method. We're going to use a format method with format method. This is something which is familiar. It's there in your strings and how to format strings. So we're going to say print sentence like that, because we already have the sentence thing, right? Then dot format. Then inside this format, the first thing is supposed to show is the first name. So you put first name, the next surname, the next the age, then the next computer number, like that. We run that, we get our stuff. Your names are John Banda, you are 18 years old, and your computer number is like that. Is that clear? The people are joining us online. Are we clear?
Yes, sir.
Okay, so basically that's how that stuff works. And if you are not sure about how this works, go back to the notes, the ones which are on the thing, the ones I've given out. Go back to the notes and study those notes and see how stuff works. Because that's the reason why I did that. So that if we have a situation we need to deal with, we just pick whatever we need. Okay? I don't have to teach things from scratch. Is that clear? So that is our Nankan exercise 3. Done. Okay. And print out the output. So it says print out the output. I'll print out print out I want the output of format string sentence with that. Okay, so basically that's all. So in this case, you are going to enter not John Banda. You're going to enter your names, your first name, your surname, first name. You're going to enter the year you're born. You're also going to enter your computer number so that this thing actually does that. Okay. Again, all these things we have done, we can get them, we put them in one thing, one cell. Okay. Now that we are sure that actually this thing works, so what do? We go back, we look. Okay, so what are we doing here? Ask the user for the surname. Okay, we ask the user for the, not this one, it's this one, yeah, this one. Ask the user for the surname and store it in a variable surname. There, you get that. Once you're sure what you have done works, actually gives you the result you want, you get that, you put it there. Okay? Then you get the code you're in for that thing to work. This one. That's the code you're in. You put it there. Next, you get the other line. Come up here. Say his first name. Yeah, here. Ask the user to enter their first name. Then this one, we'll copy it. There. Then next. Ask the user to enter their birth year. Actually, somewhere we need to make a change. I think it's better if you do that change the way than what you have done. Okay, just a minute. I'll show where. Now that we are aware that age is birth year is a string, it could be nice to change it in advance. Okay, so that we can change it in advance, then we actually store it as a number. And that's exactly what you're going to do. There. Okay. Let's. Okay, so I need to change that. Python is not very difficult. Python does things the way you do things normally. The only thing is the learning how to do the simple stuff. Because once you know how to do the simple things, for you to actually complete a task, you need to add up all these simple things you have learned into one big thing. And that is exactly what we are doing. so that we can actually solve a particular task. So we ask the computer number, and the reason why is I'm going to show very soon. Now that we know, because at first we did not know, especially when we did this part, we did not know that there was going to be a mistake. Now we know that we have got the benefit of hindsight, that okay, if it looks like when you do this and this, there's going to be a problem here. So ahead of time, we are going to sort out that, so that our program does not need to have, when the person enters the information, that potentially problematic bits is actually taken care of. So we have with the surname, first name, year, computer number. Okay. Next, the age, the year. We can ask the person to enter the year, right? Or we can just set it. Create a variable year and set it to create a variable year and set it to 2020. That can still work. So you kind of like the programmer, you have to continue there. But it's possible to get to pick the year from the computer, so that you don't have to change anything. But that's a bit of more lines, which we don't want to do. So this year. Okay. There. So what do we do here? We cast. When you change the data type of a variable, we say you're casting, okay? So we cast. So cast this cast variable base year from string to integer using int and store in and store back in base year. But so we say base year that is going to be equals to int base year. So we are changing base year. We copy base year, then we change it into an integer, then we store the copy back into base year. So we make sure base year is actually now an integer. Okay, so that bit has been done. That's a problematic part. The next, where is that? We got this. Calculate or create a variable. Calculate the age of the student. Calculate. Create variable age. Create variable age. So now age is going to be this one. Now this one is going to work. Now this one is going to work. Okay, next. Okay, we don't need this. This was because we're trying to solve the problem, right? Yeah. We come here, create string format, sentence. We create a string format. but we don't need to print it. We just need to create it. Okay. So we don't need to print it. We just need to create it. So string format. Control plus A. Let's copy. So you can select things in a cell by Control plus A, Control plus copy, and Control plus C. The same things you use in your Word. The keyboard short buttons, they work here. Then print out the output. There, print out the output. Okay. That's supposed to be like that. Okay, so we end up having this guy like that. Copy and paste. Okay, so this is becoming familiar. All the things, the separate things, as you start solving the problem, you're doing things line by line. Once you're sure the whole thing now, what you've done, the whole jigsaw is working, then you get those lines which are working, then you put them in one cell like this. Okay, you put them in one cell like this. Then you run this thing. When you run this thing, so it starts with the first line. Enter your surname. So the surname of this guy is Banda. Next, enter first name. The first name of this guy is John. Next, enter your base year. The base year of this guy is 2002. Enter your computer number. His computer number is 120.123.234, like that. Then everything has been entered. Then it prints out at the end of that. So our program works. We entered the surname Banda, the first name John, the year of birth 2002. We entered his other computer number. Then it prints out that sentence there. Your name is John Banda. You are 18 years old. Your computer number is so and so and so. Okay, so now that you have this, again, like we did for the other things, the other two cases, the next bit is maybe you want to get the information of some other student who is not John Banda, right? So what do? You get these lines. We know that they work. You get these lines, then you store them in a file. Okay? So we go back to our home page there. Then we click on new. We create a new text file. Okay. Create a new text file. So in this new text file, we say details there. We'll say get student details. Get student details.py. That will be the name of our Python program. Get student details.py. Okay. Then of course we need information about the person who wrote the program. So you can go copy a bit of that there. You paste it there, but you need to change something. Especially the exercise number. The exercise number is 3. Exercise 3. And the title of exercise 3 is here it is. List directed input output stuff. But then you put it there. Okay, put it there. Then now down here we come and we copy our whole things. We copy our stuff. Here, this whole thing, we copy it. So you say Control A, Control C, come down here, come and do a Control V. So everything has been put there. Okay? Then next thing is you save. You go to your thing. Is there something called get student details? You check. Get GGG. There. Is that Python program, the get student details. Open it. You want to be sure that everything is where it's supposed to be. So there it is. So basically, everything, all your lines you used in your Jupyter notebook, you have managed to put them in a file. Okay, like that. Then, okay, so if that's the case, then you want to see if it works. So basically, you get back to your notebook here. Then you want to run these from the file now, right? So how do you do that again? So in notebook, you say percent run, then you say get student details, just like that. So when you do that, then you run that, run, then it starts. The name of the student, Banda, okay, first name, you can say Joshua, so that we want to make sure that it's actually working. Joshua, enter, the year of birth, 2000, okay, then computer number 1 2 3 4 5 6 7 8 9, like that. Then there, your names are Joshua Banda, you are 20 years old, and your computer number is 1 2 3 4 5 6 7 8 9. Okay, this you can run it from here, or you can go to Spyder. Similarly, the way we did things to Spyder, you can go and click on open there in Spyder here. If your Spyder is running, you click on that folder there for open, click on open, then you look for the file you're looking for, get student details. There it is. You open it, and Spyder opens it. Here it is. Except it's not very Spyder thing for color stuff is not as clear as the other thing. But if you run it, you can run there. It starts asking you for things there. Okay, enter your surname, gift, Stone. So it says Stone. There, first name, gift, birth year 1986. UNZA computer number 1 2 3 4 5 6 7 8 9, because I don't remember my computer number anymore. Then it tells me, okay, your names are given to Stone, you're 34 years old, and your computer number is 1 2 3 4 5. So it works with, okay. I think we have also, yeah, we have done enough. 3 exercises is good. So there is the last bit of this thing. It's similar to this. Oh, okay, we are finished, is it? Yeah, we are finished. So lab 1 is finished. Okay, so what I am going to do is I'm going to make available. Okay, I'm going to make available this notebook. This notebook, I'm going to upload it on Moodle. So you are supposed to go, once it's been uploaded, I'll make mention, say, okay, thing is ready, it's been uploaded to Moodle. So you are supposed to go and download this thing. Okay? Then I think for me, I've already shown how to put things in a file and stuff like that. You can put your stuff in a file. Then you can send me the files. Okay, but I would want both. I would want the notebook, and I also want the files, because you have to put your stuff in files, right? So that you know both ways of working in a Python. Working with Python, there's a part where you're testing, where you're trying to make sure things are working. Once things are working, you put your codes, which have made it work, you put them in one cell. You run it, it's working, then you get that one thing, then you put them in a file. Then you have a Python program, a working Python program like that. Okay, so basically that's what is going to happen. Any questions? Those who are joining us from home?
No, sir.
Okay, you're happy about everything?
I have a question, sir.
Yes, go ahead.
I think I lost you on the part that concerns creating a text.
Creating a text file.
I haven't been clear on that part. Yes.
Okay, so the reason why you create a text file is because you don't want to go through again the same process, right? Once you have your things properly sorted out, you store your final product in a text file called a Python file. Basically, now that is your product, okay? So that anybody can access the program anytime, and no matter how many times, any number of times they want to access the program. So that's the reason why we are doing this. Say we get all these commands, the useful ones, not the ones which we're just trying to make sure if things are working or debugging, but the useful ones like this. How you get the surname of the person, the first name, the birth year, the computer number. Then you set this year, then you change birth year to that. You work out the age, then this thing, then that. These useful ones, you put them in one cell, you run it. If it works, good. Then you copy those years, then you put them in a text file. How do you create a text file? You come here. When you are running your Jupyter notebook, there is this page where it lists everything. Okay? There is this page where everything gets listed. So here, you go to the top. You get to the top here, then there's this tab here. There's a new there. With this new, it allows you to create a couple of things. It allows you to create, like in my case, JavaScript, not JS, but I'm not really comfortable with that. But there's Python, that's what you're using. So you can create by default, for you, you should have Python 3 enabled. You can create a text file, you can create a folder. You can also open a terminal session if that's what you want to do. Okay. If we open a terminal session, like where? Let me do that. So you create a terminal session in the web through your web browser instead of doing what you're doing here. Okay, let's leave. Okay, there it is. Where are we? Okay, so ls, that's everything which is there, right? So using a terminal session like that. So in this case, like the one we ran, say Python. I'm trying to show you why you should put your things in your file. Python, the first one we did, was hello world. Hello world.py. It just prints out hello world there. So once everything has been stored in a file, then you don't have to do anything. Just go and run that particular file. Then you get the results. The other one is this one, Python 3. Simple harmonic. Simple harmonic oscillator. That one there. Simple harmonic oscillator. Those are the results. So time, 8.2, position is that, growth that is that. So basically, what we have done so far is we started out with putting a single line in a file, which is the hello world.py, right? Then next, we already set some values. We given some values to use. We didn't ask for these values, right? That is in simple harmonic oscillator. Then this other one, we had to ask for values, okay? And that is Python 3. Then so you can open a terminal session using that new there. Then you go to terminal session like that. So if you are using a Windows computer, it's going to open a Windows terminal session. If you're using Linux, it's going to open a Linux terminal session. Then you use it accordingly there. Then this one was what? Get student details.py. So there. So now there you enter first name, Banda, surname, Banda, First name, John. Birth of year, 2002. Computer number, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, like that. Then the computer does everything else. Your name's John Banda, you're 18 years old, and your computer number is 1, 2, 3, 4, like that. This is the reason why you put things in the file, so that different tools can access that file. Okay, I'm not saying that this Jupyter thing is not working. No. This Jupyter thing is a tool to help you write a program which is going to work very fast. Okay? A program which is going to work very fast, because at each step you are sure what you're writing works. Okay? At each and every step as you go, you are sure your program works. If it doesn't work, like was the case, where was that? Here. Like was the case here. I didn't delete this. I just left it there to show that it's okay. There's going to be a point when you're trying to do something, then it doesn't work. Then you proceed to fix it, right? Later on, you proceed to fix it. Then when you fix it, it works. Okay? So once you are sure you have overcome whatever problems your program has and those other things, now you put everything together into this. The lines you need, okay? Not the ones you're using for fixing or trying to make sure things are working. You put everything like that. This, yes, you run the whole thing at once. Okay, it works. Now if it works, then you get that, you put it in a file. There. Put it in a file. There. Okay? You put it in a file. There. You can come back to this file next year and come and run the same program. Okay? But in our case, with that program for what's this? The program for getting the student's age. The year, the current year, there is need to get the year from the computer. Okay, there's a way you can do that, but basically that's not really the point of this whole exercise. Okay, are we clear? The people at home, are we clear?
Yes, sir.
Okay, good. All right, you guys, your first lab is done. So the only thing you need to do is you show me if you can reproduce the stuff, the goods. So I'll make the notebook available as soon as I can before the next lab session. So basically, maybe the next couple of days. Okay. All right. Yeah, so I'll keep this one. I'll create a student version. I'll do the following. File, make a copy. Then you have to fill up the things inside. Okay, we are done.
How do we have access to the videos, sir?
Yeah. How do I have access to the videos? I'll upload the videos on YouTube. Then I'll send the link. Okay? Yeah.
Okay.
Student copy. Yeah, student copy. Yeah, I'll send the link on the non-gun.
In the group.
Yeah, it's on the group.
Oh, okay.
All right.
Thank you.
Okay, yeah, cheers. Have a good day. Yeah, so basically let me start the process of rubbing things. There. You've seen what I'm doing?
Sorry?
That's what I'm doing. So you guys have to go and redo these. Yeah. So I'm going to what I'm going to share is this copy of the lab where the instructions are there, but you have to fill in the things. Okay. Yeah. Okay. How do you think about this approach? It's okay?
This one is.
Okay. Yeah, if you can do 4 labs, this is lab 1. By the end of the month, you've done 4 labs. Yeah, it's okay. It's just very important that people continue, encourage your friends, okay? That people continue coming for downloading the videos and not coming for class. Yeah. I will try. The issue, you see, the issue with the exam is also this thing, these labs, they'll ask. People do labs, okay? It doesn't matter whether, as long as people did labs. Say, yeah, we did labs, and how many did you do? We did 4 labs. It's a COVID time, okay? Then yeah, but as you're doing this, you're actually learning something on, because the whole idea is communicating with the computer so that your computer does the things you want to do. Okay? That's the whole point. Easily. But there are many there are difficult languages for doing this stuff. There are languages which are difficult for doing, but Python is one of those, comes across as easy. And very clear actually. If you have noticed what we've been doing. So like here, I'm just removing some other things. Then people have to fill in the stuff. Okay. These ones I'm leaving them. These bits, these ones I'm leaving them the way they are, so that yeah, we all have something which is consistent.
Yes.
Yeah. Banda, enter banda. Okay. What? Do the prompts. Ask the user to enter their surname with prompts. Whatever is, you're going to ask the user sounds. Print.
very much, sir.
All right.
Sure.
Cheers. See you next. See
This thing
you.
I was editing here.
Mm.
No, I don't know. Just after saving it.
Sorry. I didn't close it. Let me just open it.
Okay. So I'll set that.